So hello, my name is Derek Reid and I'm Director of the EPSRC Centre for Doctoral Training in Applied Photonics. In this short presentation, I want just to introduce you to our centre, give you some background as to what it's all about. So our centre is led by Heriot-Watt University, and it's a collaboration between Heriot-Watt and 5 other universities: Glasgow, Edinburgh, Strathclyde, Dundee and St Andrews, and it's one of the EPSRC's centres for doctoral training. The vision of our centre is all about photonic sensing and imaging. And as you watch this video, I'm sure you're aware that photonic imaging is really becoming very common in all sorts of places in our society, from self-driving cars like this one, using things like LiDAR to navigate, to Apple's iPhone that uses structured light in order to be able to do facial recognition, and things like distributed fiber sensors that are used to measure the structural integrity of large construction sites and bridges and other built infrastructure. So increasingly, this kind of ubiquitous photonic data needs to be combined with other computational techniques to really extract from it maximum value. And our centre is all about doing this. It's about equipping the next generation of researchers in this field with both the photonic skills and some of the vocabulary and understanding of computational analysis techniques that are really needed to make a difference in this very quickly moving area. So our centre addresses this training and research requirement, but does so in a particular industrial context. So a little bit now about our history. Our centre began in 2001. It was one of the first engineering doctorate centres in the United Kingdom. And in that centre, we recruited of order 15 students over about 4 years that then morphed into the CTA in microsystems and photonics. And indeed, that centre, which looks a bit like a CDT these days, we broadened the scope to include things like microsystems technology and creative 3D design. And we also developed the idea further of the engineering doctorate qualification. This was probably the first example of a full capacity centre, similar to what we run now. And in 2009, this morphed into what is the Optics and Photonics Technologies Industrial Doctorate Centre, IDC. And this was really a refocusing of our centre to concentrate just on optics. And it also broadened the range of companies that we dealt with as well. So in 2014, we had the first Centre for Doctoral Training in Applied Photonics. And following the now familiar model of the CDT that EPSRC established in that year, and in that particular centre, we addressed a theme known as integrative technologies, which emphasised the link between photonic systems and electronics. And now in our most recent centre, which began in September 2019 and had a typical annual intake of 12 students, we emphasise industrially inspired photonic imaging, sensing and analysis. So I want to say now a bit about our unique model, which is a partnership model. Not only do we have 6 universities, but we also have maybe 40 or 50 companies involved in the training of our students. And we have 2 particular approaches leading to either a PhD or an EngD, engineering doctorate degree. So still our most common qualification is the engineering doctorate research project. And in this model, a company comes to us with a research idea. We work with the company to define that into something of the scope and scale that will furnish a doctoral project. We then provide that project with an academic co-supervisor and we recruit a student. And both the company and the university contribute financially. The company contributes a larger share, and for that, it owns the intellectual property, the IP of the project, and it has the student based in the company physically on their site for the majority of their time, which is around 39 months of an industrial placement for UK students and up to 24 months for overseas students because of visa regulations. So an engineering doctorate student receives in their first year the standard EPSRC or UKRI stipend of £15,609, and then in years 2 and 3 and 4, this is topped up with an industrial contribution, bringing the stipend in those years to over £23,000. If you have a disability, you may also be entitled to a disabled students allowance on top of your studentship. And the DSA helps to cover the cost of any additional support that a person studying for a doctorate might need as a result of a disability, a mental health problem, or a specific learning difficulty. There's also a training budget that's available via the academic co-supervisor as well, and the student can access this. So in parallel, we have a number of currently fewer number of PhD research projects. These are based in universities, as is traditional for PhDs, and the model is slightly different. Here, the research idea comes from the university, and we make sure, however, that the idea is still industrially relevant and is supported by a company. And so in this case, the company provides the industrial co-supervisor, and together with the university, they prosecute the project. But here, the project is really owned by the university, although it's run in the university, and consequently the intellectual property now belongs with the university and not with the company. And reflecting that, the university pays a bit more and the company pays a bit less. The stipend arrangements are also a bit different. There's still the standard UK stipend in year one of just over £15,000, and this rises again in years 2, 3 and 4, but by a smaller amount, reflecting the fact that the student is working in a standard university environment, but it's still an elevated stipend compared to his or her peers who might also be doing a regular PhD, but not as part of a centre for doctoral training. So in this model, clearly the company and the university are involved in recruiting the student, and indeed both participate in the recruitment and selection process, including a joint interview. Let me talk a little bit now about the industrial partners with whom we work. So this is a bit of a snapshot of some of the industrial partners who are supporting current projects, but we do have a much wider range of partners who have committed to offer future projects in the centre as well. And from looking at some of these logos, you maybe see some familiar names, including large companies like, for example, Renishaw and Thales, Coherent and Canon, but also a number of smaller companies who are small to medium enterprises, SMEs. We work with a range of companies. Typically, the breakdown between large companies and SMEs is maybe 2 to 1. So about a third of our companies are small to medium enterprises. So our centre really addresses quite a range of different activities, as you can see here. We have an emphasis on things like imaging and sensing and sensors and devices, but also in instrumentation and metrology and quantum and applications of quantum technology in enabling novel forms of sensors. You would see that the emphasis was on things like imaging and sensing and sensors and devices, but also things like instrumentation and metrology. And you know, we have students based right across the United Kingdom, as you can see from this map on the right-hand side here. So although as a centre, we're based in 6 universities distributed across the central belt of Scotland up here, projects are drawn from all across the UK. So we are truly a national centre. It's worthwhile at this point to say a little bit about the mobility part of becoming a student in our centre. So all of our students begin in semester 1 of year 1 by a residential course at the University of St Andrews, where there are a couple of core modules. There is an elective module from St Andrews, and there's also a core module taught by remote learning from the University of Strathclyde. And this takes students through from September until December, following which students would typically move either to Edinburgh or to Glasgow, depending on their preference, and they would spend a further semester, semester 2, until May of that year, doing one core module at Heriot-Watt University in Edinburgh, one core module at the University of Strathclyde in Glasgow, and then selecting 2 elective modules from Strathclyde, Glasgow, Heriot-Watt or Edinburgh universities. And at this point, students finish with typically some exams in May, and then progress in late May, early June to relocate to live closer to their industrial or university project host. Right, let me say a bit more now about our training program. So one way of thinking of our CDT program is effectively that there's 1 year equivalent of full-time effort in top course training, and that embodies both technical top courses and also some business courses. There's then approximately 3 years of a research phase, as you would have understood from the previous slide. So we front load technical top course training at the very beginning of the student's time in the centre, and we do that for a couple of reasons. One is to bring together all the new cohort students in one place so they get to know each other and really develop the kind of cohort bond that is very important as students progress forward and are able to, of course, share some peer-to-peer learning as well as to get to know one another. But we also want to make sure that the technical courses and the information delivered in those courses is available to students at the earliest possible opportunity in their research project. So it's important that these courses are going to give some value to what then happens in the research phase later on. So that's why we front load them. So as I explained, students begin at the University of St Andrews, and these are the core courses that they take in two in St Andrews, Optical Imaging Concepts and the Photonics Lab, and another core course at the University of Strathclyde. And in semester one, there's a choice typically from, well, these elective courses here are those available in St Andrews: lasers, nanophotonics, advanced data analysis. Following which, in semester two, students, as I've said, progress through to Edinburgh or Glasgow. In Strathclyde University, they take a systems engineering laboratory and group project, and at Heriot-Watt University, students take a core course in photonic sensors from devices to systems. As I said, there's a wider variety of elective choices as well, drawn from our different university partners in the Central Belt of Scotland, and these are listed here. Following year one, students then are pretty much done with top courses except for business courses, and there are 3 business courses distributed typically over years 2 and 3, and these are financial decision making, delivering successful projects, and strategic marketing. And these business courses, these are formally MBA, Master of Business Administration courses, drawn from Heriot-Watt's MBA course, and these are all 20 credit courses. So in parallel with these accredited technical and business courses, we also run a number of professional skills courses that are really continuous professional development. And you can see these listed here. In year one, these include things like academic communication, equality and diversity awareness, responsible research and innovation, and some computing tools. In year two, we continue developing communication skills as well as quality management, digital outreach, and intellectual property. In year three, further communication, how to write a journal paper, and further outreach, face-to-face outreach at Glasgow Science Centre. And in year four, thesis preparation, writing, and also looking ahead, things like proposal writing and entrepreneurship. So our students come from a wide variety of backgrounds. A few are at BSc, many are MPhys, many are also MEng from electrical and from mechanical engineering. Some have previous industry experience, some are company employees, and we are seeing an increasingly balanced gender ratio amongst our cohorts, which is very pleasing, as well as an increased number of students who are either parents or carers, or of course both. And for this reason, we do our best to try and offer flexibility on a case-by-case basis as that might be required. Now, our students are a highly achieving group, and reflecting this over the past 3 or 4 years, we've been delighted that 2 of our cohort, Adam Pollack and Maria Stefania DeVito, have been successful in winning the prestigious Royal Commission of 1851 Research Fellowships. And this really shows the level at which our students operate and the relevance of their projects to the companies with whom they work. We are an inclusive centre, and we offer some flexible course options tailored to meet the needs of our students. And we do encourage you to contact us to discuss flexibility at any time. We also take very seriously the importance of equality and diversity and inclusion in our centre. All of our universities are members of the Athena Swan scheme at bronze or silver level. And in our centre, we've also worked closely with Equate Scotland to formally embed equality and diversity training into our curriculum. So if you're watching this video already, you are already aware of our website, most likely, but let me remind you, in case you have just stumbled upon this video, that there is an opportunity to find out about the latest project vacancies on our website by going to this link here. And I'd encourage you to get in touch with us if you haven't done so already. We're very accessible, we're easy to contact using the details on our website. So that's it. Please do keep in touch, and thank you for watching.